Welcome to Heavy Networking, the flagship podcast from the Packet Pushers network of fine content designed to make you the most aware, up-to-date, and educated engineer in the room. We have a network automation discussion for you today from sponsor Megaport. At the AutoCon 3 conference earlier this year, Luke Golan presented a complex network automation project that he worked on at Megaport, migrating Megaport's API-driven software-defined network from a legacy VXC overlay to an EVPN framework. And this helped improve scalability, but it was fraught with practical challenges, not the least of which was changing the engine while the plane was in flight. Luke's going to explain what he was up against here. As today's sponsor, Megaport is offering 50 of you based in the US a $500 credit to spin up cloud, data center, and WAN connections. So, for example, you need to connect AWS to Azure or extend your WAN across the planet or link data centers and cloud regions in minutes. That is what Megaport does, is what they're all about, and they want you to try out their service. They are giving you a $500 credit plus a free Megaport t-shirt, again, to the first 50 new US customers who activate their first connection. If you're interested in that, hit megaport.com/try. Again, I've actually worked with this interface a bit. It's bandwidth on demand. That's the big idea here. Point click, the service is typically running in minutes. Okay, in today's conversation, we are chatting with Luke about this VXC to EVPN automation project in more detail. And we're going to take inventory of Luke's scars, so perhaps you can avoid some of those scars yourself. Luke, welcome to Heavy Networking. And in just a sentence or two, would you tell us who you are and what you do?
Thanks for having me, Ethan. Yep, I am a network automation engineer, and I'm a network automation engineer for the automation team in Megaport. So our role as a team is to look after, I guess, all the back-end software that interacts and allows our customers to order servers, deploy services, and make changes to their services. So it's quite I guess a big realm that we look after. So we have many devices we look after. We have an MPLS network, we have a management network, we have IX route servers and things like that. So yeah, it's our responsibility to look after the code that manages, I guess, the orchestration software.
I don't want your job, man. It's better you than me.
Yeah.
Okay, so Megaport. I mean, we've talked about you guys a little bit. Megaport's been on the show before, but just a quick overview. You guys are a service provider, a global WAN provider. That's how I think of you. Is that a fair way to describe Megaport?
Yeah, I guess we're a network as a service provider. So we offer things like virtual functions and IP transit. And I guess being a software-defined network, we can give our customers the ability to turn up and turn down services or scale them whenever they like and wherever they like. So yeah, it's I guess good perks of having a software-defined network.
Yeah. When I worked with you guys on the first show that you did with Packet Pushers, I messed with that interface a bit and was able to do exactly that. Basically, map-driven, go into a particular site, click on, and I could stand up like you guys have a cloud router and so on. And yeah, it's software defined. That was like, I think when we started talking about software defined networking, what was it, 15 years ago, 10, 15 years ago? That was sort of the vision. You could, at a UI, click, set some parameters, and bang, magic would happen. So that.
Yeah, I think historically, you would email support or email your account manager, and you'd want to maybe a larger speed internet connection, and you would update your contract but yeah, I think
oh gosh, you're not
so much that, yes. You can go into the portal and go, I want to turn it down for a week because we're not utilizing the internet or VXCs as much. So yeah, huge benefits, I think. So
what it was versus what it is now, it is it
come a long way.
The future is here. Yeah, it's cool.
Yeah, it is. Yeah, it's arrived. Yep.
All right, man. So we want to review in this podcast this talk you gave at AutoCon 3. That was, you were getting into this automation project because you guys had a major service change, and there was a lot to it. Could you give us a high-level overview of this automation project? What was? Well, we should start at the beginning. What was the problem, and what was the kind of the big idea for the solution to this problem?
The problem was, I think we're always scoping out what we can improve and what our customers are asking for. So I think the best products come out of, what problems can we solve for our customers? What are they asking for? And one of those that had came up many times was, we want a VXC service with redundancy. So our VXC is just like a layer 2 Ethernet connection that our customers can use to plug from data center to data center, or they want to connect to their cloud. So it offers that layer 2 connection in between. So a lot of our customers are asking, hey, can we connect to two diverse devices on each end, and maybe have, I guess, a redundant VXC. So if the device had gone down in a maintenance, or perhaps there's an outage, then the other device would pick that up, and then the VXC would still carry traffic. So that was a question that came up a lot. So we thought, how could we solve this? And we were looking at other EVPN features, but EVPN was an obvious fit for this. The industry was moving to EVPN. Most of the vendors were supporting EVPN, and EVPN has that feature where you can offer redundancy on each side of that VXC. So that's how it came about. So we're looking at that, and then obviously you need to look at, do our devices support that? Do the version of software support that? There was other benefits, like, we were doing our VXCs are targeted LDP. So if you're moving to BGP, then obviously that's it scales a little better as well. So, and we can use BGP for other things like layer 3 VPN. So there was lots of benefits there that sort of flowed on from that decision.
So you decided on an EVPN flavor of EVPN-VPWS virtual private wire service. Why that one out of all of the choices you had?
It was simple. We didn't need Mac learning and things like that. So that was, and when we spoke to our vendors, that was the one suggested, and that from the guys testing in the lab, that was their decision to go with that technology. Us as an automation team, we had some input to that, but ultimately that was really up to the network engineering team, and we would make sure that our automation can support that. So the things that we would look at is, okay, so what does that look like when we need to deploy this in NetConf? And there's lots of design decisions that took off from that, like how do you stitch together an iBGP mesh with just under 2,000 devices. So you can't mesh everything. That doesn't really make sense. So lots of decisions went on from that. So, but I guess to answer your question there, it was simple. Talking to the vendor, that's what they were suggesting. I don't think really there was much else that would be preferred over using EVPN virtual private wire service. So,
are you in a multi-vendor environment?
Yes, we are. Yep. We have 2 vendors. So,
okay,
trying to keep with a multi-vendor environment. So,
yes,
that obviously has many benefits to
of course.
That, so,
but when a vendor says, we support that protocol, but you're dealing with 2 vendors, you got to be like, well, what does that mean? And make sure it all actually hangs together.
And how do you support that? And there are some quirks to, obviously, when you're each vendor has their own quirks and their interpretation of how they do that with the RFC. So
Okay, so you guys settled on EVPN, virtual private wire service. You've got multi-vendor environment, 2 vendors you're dealing with, and now as the automation team, you've been handed this solution by network engineering. So what are you looking at having to do to support this? Was there, like, as you're going to roll this service out, are you like dealing with a hardware challenge? Like maybe you had to replace hardware or some software stuff like, we're going to have to upgrade code or other things?
Yeah, there were lots of little challenges there. So predominantly most of the network with both of our vendors supported EVPN out the box. So we knew that when we started looking at that, saying, there's not really a lot that we need to, we don't need to replace hardware. Most of the software was already supporting that. There was a big drive, I think a year previous to that, to upgrade the network, the software on the devices. There was a portion of the network, the core network, where we did need to upgrade devices. And I think that was for our operations team to do, and they did 80 devices in around 2 weeks. So we sort of went, hey guys, we need to upgrade these devices. Do you think you could maybe do that in the next, the month or so? And it came back 2 weeks. We're done. So that was efficient.
It didn't end up being on the automation team's plate to have to deal with basically the infrastructure to support it all. Okay.
No, so I guess that's operationally things like software upgrades, and we would do the prep work, like configuration that would need to support EVPN. We do that. So predominantly our role as an automation team, anything that is configured on the network, that is us. So we're responsible with how that is deployed to the devices and what we're deploying. So But if we're backtracking to some of the decisions being made, and like when we all agreed, yep, we're going to go with EVPN, virtual private wire service, there were things like how, obviously we didn't have a BGP network. So that was one of the big things. It was like, okay, we need to deploy BGP to the entire network. So how do we,
Well, wait a
what
minute.
does that look
Obviously,
like?
you didn't know that isn't obvious, because
No.
to me, when you're a service provider, I would have assumed
No, I
that
know.
you had BGP
Yeah.
as a major function.
No, we didn't. Nope. So there was no BGP. Everything was targeted LDP, and we're using an IGP protocol for that. So that was a big thing. So we need to work out, what does the IBGP network look like? Like how are we going to do a, if you mesh everything, it's way too many BGP sessions. It's completely inefficient. So we need to look at a route server and a route client sort of scenario. So that we worked with that. Predominantly the network engineering team would decide, and they would be like, hey, this is what we're looking at. That came along with, we need to purchase some more hardware so we can support that design. And we would work with them saying, okay, what does the config look like for this? So there were new things like, we need to put BGP in the database because we track absolutely everything in a database. So we need to look at things like, okay, we need to put BGP in there. We need to work out who's a route reflector client, who's not. How do we support that in our code? So lots of little decisions needed to be made for that. So, and moving forward, like route distinguishers and things like that. So how do we generate an ID for that? And so that was the big one. And also, if you look at, you've got your design, you've got your code that supports it. How do you support devices that are coming in out of the network? So if you turn down the last MPLS link and you're removing a box from the network, you've still got all those other BGP sessions that are trying to establish to that box. So the code needs to know, okay, that's no longer relevant. We can go and deconfigure that. So there's lots of things to think about and lots of code to write to support that. So that was probably the big one, I think.
So it sounds like you're operating at a couple of layers. There's sort of the network engineering layer, and then there's the automation layer on top of that. And is that how you are organized?
I think that's fair. Yeah. So the way I guess we interact, or we work alongside our network engineering team, they would be trialing new hardware. They actually do the initial testing of, like, they have netconf, what sort of like, if you didn't know already, we rely heavily on netconf. We're not using GNMI or anything like that yet. Okay. But those guys are testing these things, right? Can we use GNMI? What does that look like? And then it would sort of come to us, and we would work with them to do that. So, but network design spec would really predominantly be those guys. So they're looking at, we need to make an architecture change, or I guess future-proofing the network as well. So,
yeah, you also said we had to put BGP in the database. What database do you mean?
Everything Megaport, I guess, like this came up a lot in AutoCon, is like the concept of source of truth. Mm-hmm. So I guess we're no different. You need to have a source of knowing what the network looks like. So our source of truth is a database. We call it, I guess we term it our networks database. So
let me be a little bit pedantic here. So what the network looks like, or what you mean for the network to look like?
Yeah, there's a couple of, I guess, this is a deep subject. So anything that wants to, for example, if you order a service in the portal or via our public API, it hits our networks API, and it does all the validations. So it makes sure that we can have have the VLANs, and make sure that we have the IP address free to support that service, whatever it may be. And then it goes allocates those resources. So the API, I guess, is doing all the validation and all the resource management. So it's putting in the database and removing the database. So if you return down a service, then it's removing all those resources from the database. It's unlinking it from the service. So the next service comes along, then it can use those. So all the code is heavily based around that. Obviously, so that's great, but obviously there's things changing on the network. So things like, I think I mentioned this in my AutoCon talk, is what happens if a device is getting swapped out? We need to know what the serial number is. We need to know maybe a transceiver is being swapped out. We need to know that. So there is some proactive, like this is where applications under our orchestration software goes out and proactively fetches those and scans the network for things that are changing. So you can't solely, I guess, 100%, manage the database based on, the API or, requests coming. We need to actively go out to the network and check things that are, maybe changing all the time. So yeah, I guess to answer your question, yeah, that is the source of truth. So there's heavy validation to make sure all the resources are correct. And we also have a full config deployment, which is going out rebuilding the network every couple of days. So there's not much in terms of network config drift. Might be digressing in your question here, but
no, but it sounds like
this is good.
Yeah, that it sounds like the goal is like pretty rapid.
I think we were super
between the
lucky.
state of the network and what's in the database.
Yeah, we were super lucky. Like I think when Megaport, we're still quite young, we're only 12 years old. So when this concept came up, and I think Mitch may have touched this on his podcast, is that it's essentially greenfields, right? So I think he had things in his head which, if I had a chance to do this on a clean slate, this is how I'd do it. So I don't think a lot of other people are in that privileged position to be able to do that. As the legacy network, and then trying to move to that would be quite difficult. But yeah, everything is in our database, and we rebuild the network every couple of days, and that corrects config drift, because that was a little bit of a problem as we were evolving from a startup company. People were still, looking around and putting a test IP address on, doing whatever, or shutting a port down, or changing a shaper maybe just to test. Maybe they suspect the shaper is broken, or they're troubleshooting it. So I guess our motto, or the way we want to operate, is that, sure, if you need some tools to do those things, we can do that. So we just need to manage it with a database. So we can grab a test IP address and we'll deploy it, and you can do your testing, but we need to know what you need to do that.
Another thing about your database, it sounds like you built your database in-house. Megaport designed this thing and it's your own, as opposed to using something off the shelf that might service this, like Netbox, let's say.
Yeah, no, it's completely in-house. The schema and everything is developed by us. So yeah, it's continually evolving as we're supporting new services like the BGP connection. So we didn't have BGP connections for our network in there. We had it for like things like IX services and that, but they were a little bit different. So yeah, this EVPN project, I guess expanded some of those the database schema to allow for things like BGP connections and route distinguishers, and later on we added a field to the VPN table to tell it if it's a EVPN signaled cross connect VXC, or if it's a layer 2 VPN. So yeah, it's always evolving, and there are some. Yeah, we decide on how best to, add those to the database and how to represent that in our schema. So yeah, it's completely in-house managed and built. So
can we get a sense of the scale we're talking about here? How big is the Megaport network, like data centers, POPs, and so on, and how much of that was affected by this EVPN-VPWS project?
Yeah, sure. So the network, it's big. It's well, I think it's big. I came from I didn't come from a network or a telco network that's expanded as far as Megaport. So I think we're covering 975 data centers now in 26 countries.
Okay.
And yeah, it's big. So well, the concept we want to get in, we want to have as many people be able to reach us as possible. So we want to expand into as many data centers as we can, so these people can connect to us in those data centers. So in terms of the network I mentioned, like we have route servers, there is a management network, and there's obviously our MPLS network, which is related to this. So we have just over 1,500 devices, which are MPLS devices, which this work impacts. So it's quite big. It's quite expansive. Yeah. So lots to think about when you're about to touch 1,500 devices. And I think in terms of VXCs and the impact for what needs to be migrated, how many, I think we're around 30,000, just under perhaps, and that is a total of just under 50,000 services. So we don't want to interrupt the other services. The goal is not to interrupt any services, right? So
Okay, so you were operating other services in addition to the VXC, and those other services.
So the MPLS network is supporting things like IX. So, we have, I think we're around 30 IXs around the world. So that's traversing our MPLS network. We have the VXC. The VXC is quite, I guess, a core product because it's stitching other services together. So you have virtual functions, which the VXC and our cloud providers. So that's how you get a virtual function to a cloud provider is use a VXC. So the VXC is quite, that's why out of the 50,000 services, 30,000 of those are VXCs.
So this is a migration project. This is not, or is it? I guess that's the question. You got a bunch of customers that are on VXC right now. You want them on EVPN eventually, or you're actively migrating all of them to EVPN?
We want to, any new services, we want them to have an EVPN underlying technology, and we want to migrate the rest. So that's the goal. So any new services that are a VXC, then you get an EVPN underlying technology. We want it to be completely seamless to the, to customers when they're ordering or our partners when they're ordering a VXC. We don't want to go, hey, do you want an option? Like everyone gets an EVPN underlying technology, and we migrate the rest. That's the aim and the goal, I guess.
So if I was a Megaport customer today with a VXC service underlying, I might not know or care about that. I care that I have my endpoints connected and I can communicate.
Yeah, so we don't want them to care. We want them to have the features and the benefits of that. So you would have things we want to aim for in the future, as mentioned, like redundancy. Hey, okay, so you have a VXC. Do you want it to be redundant? You want to terminate to redundant devices and have that sort of thing. So have those options under the VXC. So that's when you would, I guess if you were thinking about, what the underlying technology is, you go, oh, okay, perhaps that's an EVPN. The important part is to us giving them features, right? So.
Okay, Luke. So let's say I'm a customer and I'm on the let's just call it the legacy connectivity method, and it's time for Megaport to migrate me to EVPN. So is that going to be a seamless thing, or is that going to be like you need to coordinate with me because I'm going to take a hit?
Yeah, it essentially from our testing, we couldn't avoid taking a hit. So we obviously need to think about that carefully and how we could, navigate that with our customers. So there's two obvious. There was an obviously, the first thing is perhaps we can organize schedule windows with our support team. So they would go, okay, so we're going to migrate these VXCs. You would have to obviously hit 2 boxes to get each end of those VXCs. So they would correlate, a group of VXCs and organize a window with our customers. Try to find a better way which would accommodate our customers. So maybe we could move that ownership to our customers, because obviously they have doing work and maybe they're doing some work on their end where it impacts their VXCs. And we could give them the option in the portal going, hey, do you want to move your technology type to EVPN? And that's what we went with, and that's how we designed, I guess, the underlying migration. So it would look like, I guess the scenario would be, I'm doing some work which would be impacting my VXC, and I go, oh, cool, we're going to doing some night works for our particular enterprise. I'm going to take advantage of this, and I'm going to click a button, and the VXC would be transitioned to EVPN. Obviously, that would take a hit, but that doesn't matter because the particular customer or our partner has chosen to do it at that time. So they're taking ownership of it or taking advantage of perhaps some downtime that they're having. So that was the goal. So we designed the underlying code or the architecture to support that.
And so walk us through the automation then. Let's say I pull the trigger on that. I'm the customer, I'm ready to go. I click the magic boxes and it's happening. From an automation perspective, what happens next?
So there was a couple of things we had to do in the code, I guess, to support that, the customer doing or our partners doing that. So the first thing was, I mentioned before, putting a Boolean true false field in the database on the VPN table. So the VPN table has a Boolean, is EVPN signaled, yes or no. So first thing was we dropped that into the database under the VPN table. And then in the API, the networks API, we added some code to recognize that new field. So
As in you have your own API and you're now adding features to that API?
Yeah, so it'd be treated like the point is treating it like a VXC update. So if you're changing the speed of your VXC, we would treat it no differently. So we're looking at what's different in the object that they're sending with what we have in the database. We recognize, okay, that's different, so we need to change the speed. It'd be no different for an EVPN. So the back end would add an EVPN true or false. So if you're migrating to EVPN, would see a new field and it'll have true. It confers with the database and go, okay, this is not EVPN signal, so we need to, obviously they want to move to EVPN. So it would update the database to true. So it would set that new field to true from false to true. And then it triggers an update. So the update, we have a deploy agent which is looking for updates. So it's specifically for deploying configurations from our portal. So it's looking at, okay, what's a new service? What is a service that needs to be terminated? And it's looking for updates. So in this particular case, an update.
Okay, you said a really important feature about how your automation engine works. You said you have a deploy agent that is looking for changes. That is, you've got some device or some process that's sitting and is looking like at a queue. Do I have any changes? Do I have any changes? And then when it detects a change, it kicks it off into an execution engine?
Yeah, there's a few different ways, and it gets complicated pretty quickly. But I guess from a high level overview is that it's looking for terminations and new services. It's looking at a status. So if you're deploying, turning up a service in our portal, that when the API is processing that request, it's allocating all the resources, and then it sets the service to provisioning. And that is one of the statuses a service status which the deploy agent looks at. The other status is termination. So if you want to terminate, it unlinks all the resources from the service and then sets it to termination. So that's another status that the deploy agent looks at. The last one is the update. So that is like a message queuing, which it receives, and that message queue has a object of the resource that needs to update. So in this particular case, it knows it's the underlying EVPN that needs to be reconfigured, and that's how it does it. So it goes off and reconfigures the VPN. So yeah, the deploy agent is I think I mentioned this in AutoCon. It's the one of the big applications which is running deploying stuff to the network, and it's only really service specific. So yeah, it's a big job, and it's running every minute. So this is why we're quoting the 60 second deployment time. So yeah, it basically is sitting there looking at the database. Give me a list of services which are in provisioning or termination. There you go. Here's the services, and then it goes through and it goes off and removes that configuration and then updates the database. So it's a heavy lifter for sure.
Another thing you said along the way several times is the code. The code does this or the code does that. Is the code what is this, like a Python code base that or something else?
No, it's actually Perl. So
Perl. Okay, yeah.
The reason why it's Perl, I think when Megaport initially started, and it was, I guess, Mitch had the task of building Megaport, and I think there was a timeline to that. And Mitch was, and those guys were predominantly, Perl guys, I guess. So you could do Python for sure, but when you've got a timeline and Perl is your thing, I guess, then you're going to stick with that. And it's still widely supported, and people are quite surprised when it does a great job. Like I don't get into the Perl versus Python wars.
Well, no one even has that argument because it's like Python versus Go. Maybe you hear about that one, but Perl, it's sort of too bad that it was left behind. I spent a lot of years working in Perl and wrote a bunch of neat scripts that did a lot of cool things. Perl is just excellent at a lot of things. So I'm surprised to hear a network automation engine built in it, because I don't actually. Someone else has done a lot of work in PHP, which is like another off to the side. Like you can do things in a lot of different languages if they've got the library support you're looking for, and/or you're willing to write the bit you need.
Yeah, I mean, when you have a project and you have a timeline, and that is your bread and butter is Perl. Like I would be doing the same thing as well. But I guess only really it's getting harder to find, I guess, Perl developers. So that's only really, I guess, the downside of that. In terms of the code and the support and the things where you need it to do, I don't really. I think it's great.
Well, Perl isn't that hard to understand from it's not as readable as Python, right? But it's not. Yeah.
Yeah. It's different. Yeah. If you're coming from Python, I think it's different, because I had some Python skills before I started here, and was a bit of I guess initial adaptation. So, but yeah, the proof is in the pudding, right? It's running one of the biggest software-defined networks in the world. So it does a great job.
So you mentioned there's this agent that's looking for changes. Is the service being terminated or changed? And then if it is being changed, there's a configuration changes that has to happen. Is that a separate agent? Is that a human? How does that actual configuration change happen?
So the deploy agent does everything. So it's conferring with the database, as I mentioned, like what services do you have of interest that I need to deploy or terminate or update.
Mhm.
And then part of the deploy agent code is like, okay, so I need to go off and all it really needs is the configuration and how it's going to deploy that. So most of the MPLS devices are with netcomp, but there are some other devices like hypervisor hosts, which we use API calls and things like that. So to answer the question, yeah, it does. So it looks at the services that needs to deploy, and it works out what sort of config that I need to generate. Do I need to remove this service? Like, do I need to remove the configuration? And then it deploys that to the box and updates the database. So yeah, in terms of, I guess, the EVPN migration, so it would get an update. It knows that it's the VPN resource that needs to be updated. And I guess it's worth pointing out too is that we offer the option to migrate not for our services, but for our NOC team or our support team. We can go forwards and backwards. That was I guess, a criteria we wanted to set initially, just in case, you find a bug, early on. We want to be able to have the ability to move back. We're not going to, okay, we're in now EVPN and that's it. We wanted the ability to be able to roll it back just to give us some comfort, I guess. So, and the way we do that is that when it's doing an update to the EVPN configuration, it's replacing everything. So if you're going to EVPN, it's removing the layer 2 VPN bits, the legacy config, and it's adding the EVPN. If you're moving back the other way, so if we want to move from EVPN to layer 2 VPN, then it's removing the EVPN and adding the new config there. So
And is there any like post check or assurance stage to make sure the change happened and the service is up and running as advertised?
It depends what we're doing, I guess. For our customers actually get an email notification whether a VXC is up or down, so they would know. And obviously, our support team, they don't get the traps for that because there would be way too many. But our customers have the ability. We send them a notification going, "Hey, your VXC is down." So, I guess if you're doing a migration and you do not see that notification with the VXC being up, then obviously they would need to, hey, what's going? But we tested this enough to, we're confident in that, that there weren't, I guess, any issues with turning up that EVPN. We have some internal services which use that same underlying technology, and we actually rolled that out to those services internally and ran it for a good 6 months. So that gives you some comfort. So, but we do have some, I think I mentioned, when we're doing the config rollout, I'm digressing here to the network, there are some logging, and depending on those logs, we output a diff, and if there's an issue establishing a connection or something to the box, or it can't push netconf, then there is some alerting around that.
So you got some sanity checking in there, obviously. It feels like, as this conversation's gone on, so much relies on the Megaport database as your Well, okay. So do you rely on the Megaport database to avoid a screw up of something like a VLAN number collision or an inappropriate IP address being selected? Is that all reliant on the database having the information that's needed?
Yeah, absolutely. So if it's not in the database, I mean, then it really shouldn't be on the network. Besides those, I guess that 2% where we're going out and fetching transceivers and checking serial numbers and things like that. But in terms of like resources for a service to be supported, that should be in the database and is in the database. So there's a lot of code around the API and the validation of, making sure that is kept up to date. Because obviously, if it's not, you're in a world of pain, really. So,
yeah, it feels like your database is a source of truth on multiple levels. It's reflecting your intent, but it's also reflecting reality, all depending on which direction you're pushing or pulling information from.
Yeah, I mean, it's a fairly big span as well. Like it's doing things like mentioned lots of times, like VLANs and it's IP addresses. So it's managing that so there's no overlapping conflictions, but it's also checking, like, can we support this VXC from A to B? If, like, you want 100 gig from, Chicago over to London, then it's checking that. So it actually checks a primary and a redundant path that it can support that speed. And if it can't, then, we won't offer that speed. So it's a pretty broad, quite a big, broad range of validation that it's checking. So yeah, I reckon it's cool. I was like,
My brain can't take the scope of that in. It's too much. It's too many things.
And if we
that,
can't
of course,
support that, then then we need to, obviously, the right people need to know to be able to support that capacity. So and we have tools for that as well. So we have daily reports on the capacity and managing that. That's code is also doing that. So.
What kind of checks and balances do you have in place to how do I describe this? I guess limit blast radius, I guess, would be the way. Because some network changes, if you get it wrong, you can blow up a lot of stuff, not just like one device or one customer. Do you have thinking, or maybe this is more of an architectural question? I don't know.
No, absolutely. And this is something that's come up. Historically, we've been bitten by that. So historically, these are the early days, you're doing a deployment and it's just listing the devices based on a device ID. So if you look at that, when we're building a POP, things are going into the database sequentially. So, if you're going to roll out some configuration of the networking, you're doing a listing a bunch of devices, naturally they're going to occur per POP, because as they were going into the database and the deployment guys were building that POP, they're going in sequentially. So, which in turn, when you're doing a deployment, and if there is a problem, and this is what we had in the back of our head, if there was an issue with a bug, or we encountered, maybe we triggered, I guess worst case scenario where you triggered a bug and it pushes over the device. And then you go to push the next device over. You just blown a core router off in a data center, and you blew off the redundant core router, and then you just took out the two PEs which were plugged into those core routers, and the PE which was legged over to another data center. So that was definitely in the front of our minds when we were deploying. We wanted to turn up EVPN across the network, and it was actually in our minds before that. So early on, we came up with a concept with maintenance mode. So we wouldn't list the devices base, and it just returns a bunch of devices in I guess, database ID order. So we had, now the way we do it, and the concept we came up with was a concept called maintenance mode. So when the full configuration deployment, or any tools which are deploying to many devices, it looks at the code, and the code has I think it's called is in maintenance mode or maintenance window. And it's looking at some criteria. And the criteria is this device is the local time between midnight and 6 a.m. We exclude Sunday, so we don't want anything being configured on a Sunday. No one wants to be working on a Sunday, right?
Midnight and 6 a.m. local time to the device, I assume?
The device, yep. So that's a quietish period for most of our services. So that was an obvious window. And we also have a concept of device diversity. So we offer diversity for our customers, and all of our devices have a red or a blue. So we keep that even across the network. So if we have two PE routers, one will be red, one will be blue.
Hitting different NOSes, different code bases to make sure a bug doesn't take out both of those PE.
Yeah, and we also use that for scheduling maintenances. So we don't want to be, if someone wants diversity on their service, we don't want to be taking down their redundant service. So but yeah, we use this in the deployment to go, okay, we only do reds on one night and we'll do blues the next night. So yeah, to exactly your point, it's like, we don't want to be, okay, we just blew away that core router. Okay, that's a red device, so it won't touch the blue core router next to that. So that's how we lessen the impact. And so far, we haven't tested that feature yet. Touch wood. But we're always looking to improve that. So, we want to add things like, and these are in the works, is like, we want to aware of the health of the device. With, we don't want to even be blowing away all the red devices, right? We really don't want to be doing that. So we want it to be aware of, what's the health of that device after I've just done a deployment? Was there an issue? Stop if there was, or alert, and things like that. We have some alerting for if there was an issue, and so the right people are aware of that, and they know where to look, and they know who to call, or if, in a worst case scenario. So
Can you do a rollback if something went south? Do you have a process whereby you can roll back to last known good?
yeah, absolutely. So, well, we also look at the configuration changes. So when we're doing a rollout to the network of a chain, say, for example, BGP, we're adding BGP connections. When it's rolling that out, it knows that it's expecting a particular output. It knows what BGP adding a configuration looks like. So we do a diff before each commit. So what occurs, I guess, of a typical rollout, it will connect to the device. It gets the candidate configuration. It saves that candidate configuration as like a pre-config change, and then it adds the configuration. So I add the BGP changes, and then it goes and fetches that configuration again as a post change, and then it diffs the pre and the post, and it outputs that in the logging. So based on that output, if there was a port being shut down or there was something unexpected that we're not expecting, it will roll back and it will flag that as not an expected change, and it will roll back and abort that commit and then move on to the next device. And we obviously have some tracking for that. So
Okay.
yeah, you don't get the BGP connection for that device because there was an unknown change. It doesn't really happen like it, I've seen it a couple of times. But yeah, I think that's a good feature to have. So, so you're trying to avoid those cases, right? Like, the 1%ers, right? You're trying to avoid, like, this is unlikely to happen, but if it did happen, it's bad.
Okay, so in the days pre-automation, I've written lots of change control plans that always included rollback. And whenever I was writing the rollback plan, I was like, man, I hope I never have to execute this, because actually being able to
boy,
achieve
yeah.
this is going to be just brutal. I absolutely do not want to have to do this. And as a lot of folks, I've heard them describe their automation platforms, rollback's something that a lot of folks, and it sounds like you guys too, have been able to bake in, where it's more or less push button and you can get back to no good.
Yeah, it's a good point. It's a super important part of, configuration changes. I think that's where it comes to the point of, like, we try and break everything up as small as possible. So, does it really make sense? You could roll this out in one shot, right? Like, we can go and roll out lots of lines of configuration and go, yep, we're all done. We did it in 2 days. That's perfect. It makes more sense to break things up into smaller allotments or parts in case you do encounter a rollback, because it's easier to roll. We've all been there, like, if you're a network engineer and you've been on call or whatever, or you're doing maintenances in the middle of the night. I have definitely historically done a lot of changes in one window and it's gone bad, and you're trying to work out which bit made that go bad. It's hard. And rolling all those changes, and rolling all that back. So we always try and go with, okay, how can we really break this up into small parts in case we do need to roll that back? And it's easy to roll back, and we know it's pretty clear what the problem was, because we just did one change. We didn't just turn up BGP and then we added some, we turned on EVPN signaling and things like that. So we try and break it up as small as possible.
No, you've been describing a migration process, one service to another service, VXC, VXE to this EVPN, virtual private wire service. When you're done the migration and you've tested and it's successful, you've got connectivity across EVPN, are you cleaning up the legacy code that provisioned the old circuit?
Yeah, that's part of the deploy agent. I think that's what I was trying to get to with the deploy agent, and when it's reconfiguring that service. So it's blowing away the old legacy config and then deploying the new config. And that's where, I think we wanted to be able to roll back, so it blows away the EVPN and then moves it back to the L2 VPN. So yeah, it's cleaning all of that up, reflecting in the database. So there's not much really to clean up in the database. It's literally like, is this an EVPN? Yes or no, and then it goes.
Yeah.
So yeah. So that's an important part. So we don't want to be having configuration on there that's not required. So
Bless you, sir. As a guy that's come in and
This
looked
is a
at
great
configuration
part.
code base and going, does anyone know what this does? This prefix list
Yeah.
isn't applied
Oh,
anywhere.
we've all
Does
done
anyone
that,
know if we
right?
need this? And people are like, I don't know. We were too scared to delete it. You know, stuff like that. Just
This
be
is the great
crazy.
thing about, it took me a while because I initially started at operations at Megaport, and it took me a while to grasp you don't need to log on and, do those or test those changes. We have an application for that, or, things like that. And, it took me a while to, I guess, to grasp that concept of a software defined network. And it's super good to support. Like this reflects on our operations team, and we run quite a slim team because the network is super concise. It's not like, hey, we've got 20 BGP sessions that have been down for 52 weeks and they have some config, and like, oh, I need to find some IP addresses. I'll be back in 2 weeks to get a spreadsheet to sift through. Yeah, there's none of that, and that's all down to the the SDN network and the way our API is managing all those resources. So yeah, it's super cool, and it's makes the ops jobs role really not easy, but making better decisions and being more productive. They can focus on other things instead of trying to find out why a port was shut down and things like that.
So Luke, you touched on something I just want to, maybe we can wrap up on. You said you came in as operations and there was this sort of automation thing happening that kind of affected the way, you weren't used to doing operations that way. What is the relationship between sort of the automation team and the networking or the operations team? Are they touching the database? Are they relying on the database, or are things just happening and they're keeping an eye on things? I'm trying to understand. You talked about the two teams, the automation team, the network team. What is the relationship and how does it all work around that central database that's so important?
Yeah, so I think this is the part which I took a little bit of time to adjusting to. So we try and we do work closely with the operations team. I mean, they're the people who are supporting the network, right? So we need to like to know things like, what problems are you trying to solve? Like, what tooling do you need to make your job easier or better? So I was, just moving away from that CLI. Oh, we'll just go on and, I'll be quick. Okay. So moving away from that, we want to know, like, hey, you want to test an interconnect, you're turning up an interconnect to a provider, you want to test that link. So we want to know things like that, and we can build tools. So we build all the tools and we have an open discussion, schedule with those guys quite frequently, like what's happening on the network, what issues are you seeing, what can we, how can we make the tooling better, what do you need, and things like that. So
but there had to be some effort to say, look, stop going into individual devices and playing around with the CLI. We can help you do what you need to do, but we will build you tools for it that fit into this framework we have.
yeah, I think that's a discussion that I guess newer people are coming over to Megaport, and that's part of the, I guess, the induction is like, we give an overview of how we operate. Yeah, because it is different. Yeah. I mean, I had the tap on the shoulder, I think, for Mitch many years ago, going, "Hey, what are you doing?" Like, oh, whoops, you got me. But that's something that we talk about with new people, not just the operations team. People find it interesting. I think even salespeople and things like that. This is how we run the network. This is a high level overview in terms of the operations. So we have those same discussions, and it's really around tooling. So we want everything going in through the API, right? So
okay.
And we write the tools for them to do that. So even like software upgrades. We're like, I think I mentioned they did a software upgrades to 80 devices in a couple of weeks. We offer various tooling on how they do that, and we're interested to know and improve that process. Like, we're not wiping our hands and going, "Oh, cool, yep, that's good. That's a good process. Like, it's good, but can we make it better?" Like, well, and we ask those guys for feedback, and sometimes we're riding shotgun, I guess, with them and going through and seeing what challenges they have. So
yeah, the tool sets that you're giving to the engineering team, you're giving it to them because everything needs to tie into the APIs that, again, feed the database. Yeah. Okay.
Absolutely.
Well, Luke, this has been a great discussion. This is really cool. I feel like we had a little more time to develop some of the thoughts than it was a little different discussion than your NAV talk, your AutoCon 3 talk. We got to go into some interesting corners and so on. So this is great. If people have listened to this and jumped down the rabbit holes with us, and they want to ping you because they got some questions, are you accessible on LinkedIn or something?
Yeah, absolutely. Yep, you can find me on LinkedIn. Yes, luke.golan.
Excellent. Okay. And then I know Megaport, you guys are on LinkedIn. Just look for Megaport. That'll come right up. You're on X as Megaport Network. You're on YouTube as at Megaport Networks. And lots of content there if you guys want to dig into more of what Megaport is offering. And just to remind you of the special offer that I talked about at the top of the show. Megaport is today's sponsor. They're offering 50 of you that are based in the US a $500 credit to spin up cloud, data center, and WAN connections. So again, use cases for this. You want to connect your AWS and your Azure presences together. You got different locations around the planet and you want to extend your WAN to those different sites. You got data centers and cloud regions that you're trying to hook up and you want to do it quickly. You can do it in minutes with the Megaport interface. And they're giving you, again, a $500 credit. Free Megaport t-shirt to the first 50 new U.S. customers who activate their connection. So hit megaport.com/try if that is interesting to you. And thanks for listening to Heavy Networking today. We really appreciate it. And if you do give Megaport a try, tell them that you found out about them on Packet Pushers. That helps us out as sponsors pay our somewhat considerable bills. We do like it when sponsors come back to sponsors again, because you folks are discovering useful services for your organizations. Like, share, and subscribe to this show. Tens of thousands of you are subscribed to Heavy Networking, but we know there are millions of network engineers out there. So spread the word by sharing this podcast with a friend, and also by threatening to DDoS their network if they don't subscribe. I'm just kidding. Don't do anything to get yourself in trouble. But do share this podcast with your friends, seriously. Or if you're talking to other humans, maybe you find that difficult, because I'm right there with you, honestly. Why not spread the joy of Packet Pushers by wearing a snazzy shirt or drinking from a cool mug from our merch store at store.packetpushers.net? That would get the job done too, and you don't have to say a word to anybody. We are going to see you in the community Slack group and the newsletter, folks. And until next week, just remember that too much networking would never be enough.